Welcome, cosmic explorers. We're about to embark on a journey that will challenge everything you thought you knew about life. Today, we're peeking behind the curtains at 12 other potential stages where the drama of life could be unfolding. So buckle up, keep your mind open, and let's blast off into the unknown. First stop, our nearest planetary neighbor, Venus. Now, I know what you're thinking. Venus? That cosmic oven where lead melts on the surface? Not exactly a vacation spot. But hold on to your space helmets, because we're not talking about the surface. About 50 kilometers up in Venus' atmosphere, there's a sweet spot. The pressure and temperature here are surprisingly Earth-like. But instead of oxygen, the air is filled with sulfuric acid clouds. Sounds nasty, right? Well, not if you're an acid-loving microbe. Some scientists believe that microbial life could exist in these clouds, floating carefree in the Venusian sky. These hypothetical sky dwellers would need to be tough. Think tardigrades on steroids. They'd likely have evolved acid-resistant membranes and might even use the sulfuric acid in their metabolism. In 2020, researchers detected phosphine in Venus' atmosphere, a gas that, on Earth, is produced by living organisms. Could this be a sign of Venusian life? The jury's still out, but it's got us looking at our evil twin planet in a whole new light. Next, we're diving deep, really deep, into one of Jupiter's moons, Europa. This icy world might look like a giant snowball, but beneath its frozen surface lies a secret, a liquid water ocean that could contain twice as much water as all of Earth's oceans combined. But how can liquid water exist so far from the sun? Thank Jupiter for that. Its massive gravitational pull causes Europa to flex and stretch, creating friction that heats the moon's interior. This process, called tidal heating, keeps the subsurface ocean from freezing solid. Now, why are we so excited about this hidden ocean? 2 words: hydrothermal vents. On Earth, these underwater hot springs are oases of life, teeming with bizarre creatures that thrive on chemical energy instead of sunlight. If similar vents exist on Europa, they could provide the perfect conditions for alien life to evolve. Imagine creatures gliding through pitch-black waters, perhaps using echolocation like dolphins, or bioluminescence like deep-sea fish. They might feed on nutrients seeping from the ocean floor, or on each other in a complex food web we can only dream of. Our next stop takes us to Saturn's largest moon, Titan. This world is unique in our solar system. It's the only place besides Earth known to have stable liquid on its surface. But we're not talking about water here. On Titan, it rains methane, and the lakes and seas are filled with liquid hydrocarbons. It's like Earth's oil fields decided to take over an entire world. The temperature here hovers around a chilly minus 179 degrees Celsius, minus 290 degrees Fahrenheit. Way too cold for water-based life as we know it. But could life find a way in this hydrocarbon soup? Some scientists think so. They propose that life could use liquid methane as a solvent, the way Earth life uses water. These hypothetical creatures might have cell membranes made of nitrogen-based compounds, breathe hydrogen instead of oxygen, and metabolize acetylene instead of glucose. Imagine alien fish swimming through methane seas, or strange plants absorbing Titan's dim sunlight, converting acetylene into methane instead of CO2 into oxygen. It's a completely alien biochemistry, but in the grand universe, who's to say what's truly alien? Now, let's take a trip to everyone's favorite potential second home, Mars. But we're not here for the rusty landscapes you've seen in rover photos. We're going underground into the vast network of caves that honeycomb the Martian subsurface. These caves aren't just empty spaces. They're potential shelters from the harsh surface conditions that make life on Mars challenging. Down here, away from the intense radiation and extreme temperature swings, life might find a foothold. Some of these caves might even contain ice or liquid water. Imagine microbial mats clinging to cave walls, feeding on minerals in the rocks. Or perhaps more complex organisms have evolved, with eyes adapted to the perpetual darkness, sensing their way through echoing caverns. The best part? We might actually be able to explore these caves in the near future. NASA is developing cave-exploring robots that could one day search for signs of life in these Martian underworlds. Hold on to your helmets as we zip to another of Saturn's moons, Enceladus. This icy world is putting on a spectacular show, with geysers of water vapor shooting from its south pole. But these aren't just for show. They're telling us something exciting about what's happening beneath the surface. These plumes suggest that Enceladus has a global subsurface ocean, kept liquid by tidal heating, just like Europa. But Enceladus goes a step further. The Cassini spacecraft flew through these plumes and detected organic compounds and molecular hydrogen, potential food for microbes. Scientists believe these materials could be produced by hydrothermal vents on the ocean floor, similar to the ones we have on Earth. In our oceans, These vents support rich ecosystems without any need for sunlight. Could the same be happening on Enceladus? Imagine a world of microscopic aliens clustering around warm vents, turning hydrogen and carbon dioxide into methane. It's like a deep-sea spa day, but for microbes. Buckle up, because our next stop is not for the faint of heart. We're heading to Io, Jupiter's innermost large moon and the most volcanically active body in our solar system. This place makes Hawaii look like a cold shower. Io is covered in hundreds of volcanoes, constantly erupting and reshaping its surface. But instead of lava, many of these volcanoes spew out molten sulfur, creating lakes and pools of liquid sulfur on the surface. Now, you might think this sounds too extreme for life, but don't be too quick to judge. On Earth, we found microorganisms thriving in volcanic hot springs, and even in pools of concentrated sulfuric acid. Life, as they say, finds a way. Hypothetical Ionian life might use sulfur in its biochemistry, the way Earth life uses carbon. These sulfur-based organisms could feed on the energy from Io's constant volcanic activity, perhaps forming mats around the edges of sulfur lakes or even floating in the molten sulfur itself. It's a hot, acidic, and downright hellish environment by our standards. But in the grand cosmic scheme, it might just be paradise for the right kind of life. Now we're venturing beyond our solar system to a planet that's captured the imagination of astronomers worldwide, TRAPPIST-1e. This rocky world is one of 7 planets orbiting a red dwarf star about 39 light-years from Earth. What makes TRAPPIST-1e so intriguing? It's smack in the middle of its star's habitable zone, the Goldilocks region where liquid water could exist on the surface. But don't expect Earth 2.0. This planet is likely tidally locked, meaning one side always faces its star. Imagine a world where one hemisphere is in perpetual daylight, while the other is in eternal night. Life here might thrive in the twilight zone between these extremes. Picture plants that have evolved to use the infrared light from the dim red star, or animals that migrate with the Terminator line to avoid freezing or burning up. The challenges? Intense radiation from solar flares and potential loss of atmosphere. But if life emerged here, it might have evolved robust defenses against these cosmic assaults. Our next stop is Ganymede, Jupiter's largest moon, and the only moon in our solar system known to generate its own magnetic field. This is a big deal in the search for life. Ganymede's magnetosphere acts like a shield, deflecting harmful radiation from Jupiter and the Sun. This protective bubble, combined with evidence of a subsurface ocean, makes Ganymede a tantalizing target in the search for extraterrestrial life. Life here might be sheltered in the ocean beneath the icy crust, protected from radiation by miles of ice and the magnetic field above. These organisms could range from simple microbes to more complex creatures, perhaps using magnetoreception to navigate through the dark waters. The interplay between the magnetic field and Jupiter's intense radiation also creates aurora on Ganymede. Imagine alien life forms that have evolved to perceive these shifting curtains of light, using them for navigation or even communication. Strap in, because we're heading to the outer solar system to visit Neptune's largest moon, Triton. This bizarre world is the only large moon in our solar system that orbits in the opposite direction of its planet's rotation. But that's not the strangest thing about it. Triton is home to cryovolcanoes, ice volcanoes that erupt plumes of liquid nitrogen, dust, and methane compounds. These eruptions create temporary atmospheres and could potentially distribute the building blocks of life across the moon's surface. The surface temperature here is a frigid minus 235 degrees Celsius, minus 391 degrees Fahrenheit, but the presence of cryovolcanism suggests internal heat. This could mean subsurface pockets of liquid water where life might huddle for warmth and protection. Any life here would need to be extremely hardy, perhaps creatures that can enter a state of suspended animation during the harsh surface conditions, only to spring to life during eruptions. Or maybe microbial life forms that float in the nitrogen plumes, colonizing new areas with each eruption. Triton shows us that even in the coldest, darkest corners of our solar system, the potential for dynamic, life-supporting processes exists. Our journey takes us to the edge of our solar system, to a world once considered the 9th planet, Pluto. This distant, icy body holds a warm secret beneath its frozen surface, a potential subsurface ocean. New Horizons flyby revealed a surprisingly active world, with nitrogen glaciers and ice mountains. But the real excitement lies beneath. Models suggest that an insulating layer of gas hydrates could keep a liquid water ocean from freezing solid, despite Pluto's extreme cold. Life in this dark, pressure-packed environment would be unlike anything we know. Imagine organisms that have never seen light, using chemical energy from rock-water interactions to power their existence. They might communicate through vibrations in the ice shell or even bioluminescence, creating their own light in the perpetual darkness. Now, let's venture into the spaces between stars to find our next potential home for life: rogue planets. These are worlds that have been ejected from their star systems, drifting alone through the cosmic void. At first glance, a starless planet seems an unlikely abode for life. But these cosmic nomads might have surprises under their frozen surfaces. Internal heat from radioactive decay could maintain subsurface oceans for billions of years. Life on a rogue planet would be totally independent of starlight. Imagine ecosystems powered by chemosynthesis, or organisms that harness the planet's magnetic field for energy. These life forms might even be unaware that other stars exist, evolving in splendid isolation in their dark, wandering world. Our final stop brings us to objects that blur the line between stars and planets: brown dwarfs. Too big to be planets, but too small to sustain hydrogen fusion like stars, these cosmic in-betweeners have incredibly complex atmospheres. Brown dwarfs have cloud layers made of exotic materials like vaporized iron or silicate dust. Some are cool enough to have water clouds, much like Earth. These varied atmospheric layers could provide niches for different types of life. Imagine organisms floating through iron clouds, harvesting energy from the brown dwarf's residual heat. Or perhaps life forms that migrate between different cloud layers, adapted to extreme pressure changes and varied chemical environments. The possibility of life in brown dwarf atmospheres pushes our imagination to the limit, challenging us to think beyond the constraints of planetary surfaces. As we conclude our cosmic tour, we're left with a profound realization. The universe is stranger and more wondrous than we ever imagined. These 12 extreme environments are just a glimpse of the incredible diversity of worlds that exist in our galaxy alone. So, what do you think? Which of these environments excites you the most? What kind of alien life do you imagine might exist there? Share your thoughts in the comments below, and don't forget to like and subscribe for more cosmic content. Until next time, keep looking up, keep wondering, and remember, in a universe this vast and varied, the possibilities for life are truly endless.